So welcome students. So in this question you're given that you have a cube and the vertices, the corners of the cube are cut in the form of equilateral triangles. So let this be the original cube. What I have done is I have cut the edges of the cubes. You have 8 edges, 1, 2, 3, 4, 5, 6, 7 and 8. So at these 8 edges we have cut the cube in the form of equilateral triangles. So can you see what is happening? So these are the equilateral triangles that I have cut. So now what is being asked is, so how many diagonals of this figure will lie completely inside the cube? So how many diagonals of this figure will lie completely inside the cube? Now how do we analyze this? So the first is, let me count the number of vertices that this cube has. How many vertices does this cube have? So as you can see, every corner of this original cube has been converted into 3 corners. Every corner of the original cube has been converted into 3 corners. So the number of corners, so the number of corners, so the number of corners will be equal to 24. So is there any doubt about this? So the number of corners will be equal to 24. So once you have 24 corners, so how many total lines can be drawn by joining these 24 points? So if you want a line, you can join any 2 points. If you join any 2 points, you get a line. So number of lines that can be formed by joining any 2 points is equal to, so the number of lines is nothing but, so 24 C2, because you have 24 points. If you join any 2 points, you get a line. So you have 24 C2 lines, that is equal to 24 into 23 divided by 2, that is equal to 23 into 12, that is 230 plus 46. You have a total of 276 lines. So out of these 276 lines, not all of them are diagonals. So first, what are the lines which are not diagonals? The lines which are not diagonals are, the first is the sides of the cubes. How many sides does this cube have? The sides of the cube, how many sides does this cube have? If you count them, so the number of sides is, there are originally 12 sides, 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10, 11, 12. All the sides are intact. If you can see, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All the sides are intact because the side is not completely cut. Only half of the side is cut, and according to, for each corner you got 3 extra sides. For each corner you have 3 extra sides, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 11, 9, 10, 11, 12. You have 12 sides and 12 sides below. You have 24 plus 12 original sides. You have number of sides is equal to, so number of sides or edges of the cube, number of sides is equal to 12 original sides plus 24 extra sides. So that is equal to 36. So out of these 276 lines, 36 are sides of this cube which are not diagonals. And the other problematic parts are the diagonals of the faces. So number of face diagonals, So how many face diagonals are there? So as you can see, So each of this face, in the original cube, each face is a square, but once you cut these equilateral triangles, so can you see that each face is an octagon? So each face is an octagon. 1, 2, 3, 4, 5, 6, 7, 8. So each face is an octagon. So the bottom face is an octagon. So every face is an octagon. So how many diagonals are there for an octagon? So the number of diagonals of a polygon is given by n into n minus 3 by 2. That's the formula for number of diagonals for an n-sided polygon. So if you have an octagon, n is equal to 8, so that is equal to 8 into 5 by 2, which is equal to 20. So you have 20 diagonals for each face of this cube. And how many faces does this have? You have 20 faces. Sorry, you have 6 faces. So the total number of diagonals is equal to 6 into 20, which is equal to, so 120. So these 120 lines also come in this 276 lines. So apart from these 36 and 120, all the remaining lines will be the diagonals of this cube. So what is the number of diagonals of this cube which lie inside this cube? So 276 minus 120 minus 36. So that is equal to, so 276 minus 36 is 240. 240 minus 120 is 120. So there are a total of 120 diagonals to this cube which lie completely inside this cube. Thank you.